Hello and welcome to our Geography 1820 Intermediate GIS course at Salt Lake Community College. Chapter 1, Introduction to GIS. So in this lecture, in this set of slides, we're going to talk about what GIS is, talk a little bit about data, where to get it, some examples of how it works, how we can use it, and an overview of the software as you dive into GIS. So let's talk a little bit about what GIS is. So when we say GIS, we're referring to an entire suite of hardware and software that are used to analyze data that has a spatial component. All data, pretty much all data, has a spatial component, so that and when you analyze such data, you get a much different view of what is included in the data patterns when you look at it on a map rather than just in a table. Pretty much any field can have an application for GIS. I've run into very few where I couldn't come up with some application where GIS could be used in a major or a career or a profession. So what's so unique about it? It's a data analysis tool, right? It does have some unique capabilities. GIS can, as a system, can find or show you as an analyst relationships in different data sets that of a spatial nature. Call those map layers. You can lay them on top of each other and find these patterns. And you can also use them for cartography. You stack enough layers on top of each other, you're going to find correlations and relationships. So you can use GIS to answer a whole bunch of questions. What's there? Where is something? What kind of what's the status of something? Name something. What's changed since? You can use time series data to look at change over time. You can find the spatial patterns that we talked about. You can use it to build models to look at possible, what happens if certain actions are taken or not taken. So GIS data works on a geographic scale. So we're all familiar with world maps, world globes at what would be a very small scale, since scale is a fraction. So small numerator, large denominator is a small scale map, which means it covers a large area. Large scale maps cover a smaller area in a much more detailed manner. And when you're collecting GIS data, it's often helpful, well, it's always helpful, to know what scale that data was collected at for it to be valid. If you have global data and you're using it on a local scale, the accuracy is probably not going to be there to allow you to make any meaningful assessments of any relationships in the data, just because the accuracy isn't there because of the scale. So there's two main families of GIS data, of spatial data. Vector data, which is their features, is what we understand as objects in real life, points, lines, polygons, are the three major geometries that are used in vector data. Each one of those features also can have a number of attributes. So in the table here, you see that we have points representing cities in the United States, and some of the attributes that are attached to them. What's the population? What state is it in? On and on. So keep that in mind. You can have multiple attributes per feature. Now the other type of data is called raster data. This is data that is not point specific. Okay, think of an aerial image, okay, or even a digital photo. That digital photo is made up of pixels, small squares that store information. In the case of a digital photo, that information it stores is color, what color that pixel is, and that creates the picture. The difference between raster data and vector data is raster data can only store one attribute at a time. So in this case, color. You can't store multiple attributes. Now, one thing that raster data does allow you to do is to layer different raster data sets on top of each other and perform what's called map algebra. You can add, subtract, multiply, divide with numerical attributes. So you can do quite a bit of analysis on raster data, and there are some data sets that lend themselves much better to raster applications than vector data. I'm thinking of things like precipitation or elevation, things that change over the surface of the ground. So keep that in mind. There are applications for both, although most of what we'll be dealing with in this class will be vector data. So how has GIS evolved over time? It certainly came into being with the advent of the computer, and has come a long ways since then. It started in the 60s. A man named Roger Tomlinson in Canada, who is widely regarded as the father of GIS, developed the first computerized GIS, Geographic Information System, to help with land use management and resource monitoring. GIS has a rich history in those fields. Howard Fisher at Harvard also got into the game about this same time with his lab in computer graphics. So the analysis, the graphics, all came out of those early years in the 60s. Also in this time was Jack Dangermond. So the software we're using in this class is from Esri, which was founded by Jack Dangermond in the late 60s. He's still around, still involved in the GIS world, and we'll have a couple of video presentations from him later on in the class. Also at this time, the GPS system came into operation. Originally it was strictly for military use, but it laid the foundation for the current GPS systems that we have today in everybody's phone and car, and just about everything else is location enabled. Came out of this in the early 60s and 70s. So during the 80s and 90s, which is when I learned GIS, it started to move into the realm of desktop applications. Before it was in the realm of the supercomputers and high-end graphics machines. So in the 80s and 90s, it started to move into more of a desktop environment. The main product was ArcInfo. What it was called, it was a Unix-based program that ran command line. You had to type everything in to make it do what you wanted. But there were other programs around. MapInfo was a light GIS, if you will, good for map making, not so strong on the analysis. Some other companies, Autodesk, Intergraph, really tried to get into this market. And as you can tell, since we're using Esri software, didn't really make it. So currently, we are in a desktop GIS world. ArcGIS is the platform we're using, and compared to the even the mid 90s ArcInfo that we were using in graduate school, it's much more powerful, much more user friendly, and much better on the cartography aspect of map making. You make beautiful maps with it, and that's where Esri has really poured a lot of resources, is into the cartography aspect. But there's some up and coming areas. Some mobile GIS, we'll dig into that a little bit this semester, as well as some online solutions. ArcGIS Online. Everyone is probably familiar with Google Maps and Google Earth. People are fascinated by maps, by aerial imagery, and so we'll dive into that a little bit during the semester. So let's talk a little bit about GIS data, the layering that you can do to help answer questions. Okay, so the example we have here is we are GIS analysts, and we have been asked to identify the location of companies that are spewing a lot of pollution and their proximity to populations in poverty, water features, and schools. Okay, so that's our problem. That's what we've been tasked to do. So let's think about that. How are we going to do that? So we have data. We have databases that have. So our top table here is our census tracts with information about income and poverty. The second table here is a database of companies, what industry they're in. That's the SIC code in column B, as well as the latitude and longitude, and how many pounds of pollution they're spewing. All really good data, but it's not really easy to interpret. You can't really make any correlations between those, because you don't really know where tract 101 is in relation to the that number 2, row number 2, paper and allied products at 44 degrees north and 93 degrees east. So we're going to change that. We're going to use a map. So we're going to plot these two data tables in a map. So both of those tables in the previous slide had location information, census tracts, and the companies. So we have a map here showing our census tracts in the light gray outlines, and the companies plotted as dots that are representative of how much pollution they're producing. So instantly now we can see, all right, we have some interesting relationships that we can see. Okay, we can see those darker census tracts with more poverty are also proximate to some of the larger polluters in this example. So instantly, by putting it on a map, you find those relationships. Okay, so we've added some municipality layers to the map. The water features, okay, lakes, rivers. Here's our schools. Okay, all of this data is available. You have to create very little of your own data. It's mostly finding data that's already been created, ascertaining whether or not it's useful for your use, and then bringing it into your map. Okay, so now once we have it in here, we can use our identify tool in ArcGIS to identify which of these features is which. So it has an interactive capability too, whereas if you print out a map, you lose that. But by having it electronically, you can use those interactive features. So if you select a feature on the map, that corresponding feature will highlight in the attribute table, and vice versa. If you highlight something in the attribute table, the same feature will be selected on the map. So you can see that correlation between those the tabular data and the spatial data. You can also use the location tools to select features by location, by proximity to other features. So in this case, we're showing, we're going to select the polluters, the polluting companies that are within a quarter mile of a water feature. Okay, that's in that box there that says select by location. That's what we're seeing, and you can see in the map behind there that it's selected three features that are within that quarter mile buffer. So we can also find do a buffer, a radius buffer around points, lines, and polygons. So in this example here, we're showing schools and children within a 2-mile buffer of a polluting company. So we identify which companies we want to buffer. We use the buffering tool to create that buffer. Then you can select those schools, and data from the census tracts that fall within that buffer. So now we can drag some statistics from the tables. So we have the tracked data here within the pollutant buffers, and we can do some basic statistics. The mean is the mean of the population in poverty is 23%, as opposed to 10% outside of those tracts. Percentage of children under 18 is higher in those tracts. Mean income is less than half, or around half, of what is in the tracts outside of those buffers. So we found some others here. Schools, 25 schools, total enrollment you can get data for. You can get racial breakdown, all from that question we were asked, and using the spatial capabilities in the GIS software. All right, so I'm going to pause here for a moment. There's another YouTube video on the overview of how the software works. That's a separate video, so we'll I'll have that on the Canvas page as well, so you can where I show you some of the tools, how to access them in the software. So go there, watch that. So in your textbook, in each chapter is a series of tutorials that will cover the topics that we're going to be dealing with in the assignment. Each chapter will be followed by an assignment for you to do. All that you need to know to do those assignments is in the tutorials. So I would highly recommend you going through those tutorials until you're comfortable with the software, with the tools that are being shown, and yeah, so just get familiar with it. Some of you probably are, some of you may not be. So it's up to you to get up to speed on that and then go into the assignments. I'll do a separate video of the assignment. I'll walk you through it, how to, what steps you need to take to successfully complete the assignments. The assignment for this chapter is 1-1. It's on page 42 of your textbook, and you're going to take data from the Census Bureau, and you're going to do a basic analysis of population by race in the top 10 U.S. states for total population. So hope you stick with me for chapter 2 and 3 and 4 and up to 8, and so go to it, have fun with it. Don't worry about it. You can't break it. So don't be hesitant. Have at it. Okay.